So up until now, you only know a couple of things about acids and bases. You know the definition of an acid is anything that increases the H plus or the H3O plus concentration in solution. We know that an acid is something that can donate a hydrogen. We know that a base is something that increases the OH minus concentration in solution, and it also can accept a hydrogen. Those are the four definitions of acids and bases that you're supposed to be familiar with understanding. We also know about conjugate acids and we know about conjugate base pairs, but we haven't really discussed the big part of this unit, which is pH and calculations that are associated with it. So the first thing that I need to tell you about is that acids and bases, they have this pH range that go from somewhere that start with 0 and they go all the way to 14. And anything that's considered an acid has a pH that is less than 7. So 6.9 and below is considered acidic. Anything that's considered a base is anything that has a pH greater than 7. So like 17.01 and above is considered a base. And everything that has a pH that is equal to 7 is something that we refer to as neutral. So in our experience, the thing that has the pH closest to 7 in your chemistry life is deionized water. Everything else that you've ever dealt with in any way, shape, or form is considered to be an acid or a base. So going along the pH scale, that's this picture over here on the right, we have things like battery acid and sulfuric acid and lemon juice and orange juice and soda and acid rain and acid lakes and bananas and healthy lakes and pure water and all those, everything up to pure water is acidic, okay? Well, that's the issue. I realize that the more acidic something is, the lower its pH is. However, the issue is that some people might be like the question that you asked is like, isn't acid rain like really, really bad and doesn't like melt your face off? And the answer to that question is acid rain is relatively is dilute, but it still has a pH of 4. So when it hits the ground or when it hits you, it doesn't necessarily sting you, but it will break things down over time. So like the same thing applies to orange juice. Orange juice is acidic, but it has a pH of 3, and it's a pretty acidic solution. But the issue is that because it has so much water in it, it still has a pH of 3, but it's not going to like burn your face off as if it were pure acid. Sebastian?
Why do they always say liquid drain cleaner is an acid if it's not?
I don't know anybody that's ever said it's an acid.
Whenever you go to the store, they say it's an acid.
Well, it depends on the liquid drain cleaner. So, for example, you can buy acid to pour down the drain. That is a liquid drain cleaner. But like your commercial things like Drano and those things are definitely basic. Chase.
So what makes like peppers like sticky then? Is that?
That has to do with a compound called capsaicin, and it is somewhat acidic, but it's not quite the same as the acids that we're talking about here. Sammy?
So is it like really bad if you put something super acidic in your in your eyes? Because like certain patty, you know what it is?
I'm moving forward. I have no idea what you're talking
Is there
about.
anything
Like pure water, other than pure water?
Yeah.
Generally speaking, no.
Like what happens if you put battery acid?
Oh my God. Now,
Legit.
what?
Yeah, what do you do if you what happens if you go blind?
If you put battery acid on your skin, you get a chemical burn. If you put it in your eye, you will more than likely damage your eye to the point that it may not recover.
What about like lemon juice?
Well, again, lemon juice is pretty dilute. It's going to sting a lot, but you'll probably be fine. That seems like a stupid conversation. Now, water, ladies and gentlemen, has the ability to do something that we call self-ionize, but it does this in very small amounts. So we learned already that water can act like an acid, water can act like a base, because it's amphoteric. It can accept a hydrogen, it can donate a hydrogen. But what water will do on its own is it will break apart and reform into H3O plus and into OH minus. So if H3O plus is something that's considered an acid or associated with acid, and OH minus is something that is associated with a base, usually, then when water self-ionizes, what ends up happening is we produce a little bit of acid content and a little bit of base content. But when this equation above is balanced, we have the concentration of H3O plus equaling the concentration of OH minus. So when you see something written in brackets, those brackets are symbolizing measure of concentration or molarity. So at 25 degrees Celsius, water will self-ionize and produce a very, very small amount of H3O plus. Water will self-ionize and produce a very, very small amount of OH minus. For example, we're talking about that much H3O plus and that much OH minus at room temperature. So it's not a lot, but it is measurable, and it is something that we are able to keep track of. So water will do what we call self-ionize and produce this very, very small amount, especially of H3O plus and OH minus, especially if it's considered pure water. Why this is important is because the ionization constant of water, something that we refer to as Kw, is something that will allow us to calculate different concentrations of H3O plus and OH minus. So in this case, the constant for the H3O plus and OH minus is the product of the concentration of H3O plus times the concentration of OH minus in pure water. So if I have 1 times 10 to the minus 7 times 1 times 10 to the minus 7, that gives me a Kw value of 1 times 10 to the minus 14, which you should probably memorize. So the Kw value allows me to now go ahead and calculate an H3O plus concentration if I know an OH minus. It allows me to go and calculate the OH minus concentration if I know an H3O plus. But what you really should probably understand also is the fact that the relationship between hydronium ion and hydroxide ion is inversely proportional. So if I increase the concentration of hydronium ion, the concentration of OH hydroxide ion has to go down because it always has to equal 1 times 10 to the minus 14. So in a neutral solution, hydronium ion equals hydroxide ion. In an acidic solution, hydronium ion is greater than hydroxide ion, and in a basic solution, hydronium ion is less than hydroxide ion. You should probably know this because you are going to be asked to identify whether or not a solution is acidic or basic based on the ion concentrations present. So you should probably memorize that. Now, aqueous solutions and calculating hydronium ion and hydroxide ion concentration go a little bit, are not difficult math, but they're just something that we need to work through. So if I tell you that you have the strong acid HNO3, what about it makes it a strong acid? The hydrogen makes it an acid, but what about it makes it a strong acid? What makes a strong acid different than a weak acid? Thank you. So if it's a strong acid, it will completely dissociate into H plus ion and NO3 minus ion. Okay? Now, the issue from this point forward, anytime that I tell you that we're working with H plus, for this unit, H plus is pretty much synonymous with H3O plus. Now, another thing that you should probably be aware of is that if I have a concentration of HNO3 to be 1.0 times 10 to the minus 4 molar, when that breaks apart, because the ratio is 1 to 1, this is also 1.0 times 10 to the minus 4 molar. And this is 1.0 times 10 to the minus 4 molar. Okay? So in a strong acid solution, when it dissociates or breaks apart, I know the concentration of both of the ions. And in this particular case, since I'm being asked to calculate H3O plus and OH minus, and because it's an acid, and it's a strong acid, I get to assume that I know the concentration of H3O plus. So if I'm gonna take KW is equal to H3O plus times OH minus, and I know that KW is always has to be 1.0 times 10 to the minus 14, and we just determined that H3O plus's concentration is 1.0 times 10 to the minus 4, I can now go ahead and calculate the OH minus. So in this case, I'm going to get 1.0 times 10 to the minus 10 molar for OH minus. Now I realize that it looks like it's pretty simple, and just using the addition and subtraction properties of exponents, you should just be able to subtract, but they're not always going to be this simple. Any questions about this? Sebastian?
I understand 100% what you're talking about all the time. No, I'm good. Thank you though.
Can I move on?
Yes.
For the other example that we're going to do, I'm asking you to determine the hydronium and hydroxide ion concentration for a solution that is 3 times 10 to the minus 2 molar sodium hydroxide. Sodium hydroxide is what? An acid or a base? Sebastian, is this an acid or a base?
Definitely an acid.
Try again.
Definitely a base.
How do you know?
Because it wasn't an acid.
Somebody want to help him? Because it has an OH. And I'm telling you that it's a strong base, so NaOH is going to completely dissociate into sodium ion and hydroxide ion. And if I know the concentration, I know the concentration of the hydroxide. Okay? So if I'm asked to calculate the hydronium ion concentration, which is this, and the hydroxide ion concentration, which is this, I'm going to use the KW formula, which we know is 1.0 times 10 to the minus 14. But because this is a base, I know that hydroxide is going to be 3.0 times 10 to the minus 2 molar. So KW is equal to concentration of H3O plus times concentration of OH minus I get a value for H3O plus to be somewhere around 3.3 times 10 to the minus 13.
Mr. B,
What?
how do you know that it's 1.0 times 10 to the minus 14?
The value for KW, which is the equilibrium constant of pure water, from the auto-ionization of water, we know that it always makes H3O plus, which is 1 times 10 to the minus 7, and OH minus is always 1 times 10 to the minus 7. Those in pure water multiply to 1 times 10 to the minus 14. So this is the constant you have to memorize.
All right.
Sammy?
So what, don't you define the hydronium ion?
I just did.
Probably a small question, but why is it 3.13? My answer is just the way you calculate. Are you dividing the two?
Yeah. So I'm doing, so think of H3O plus as X.
Dropping it down to the power? Okay.
Well, I just divided 1 times 10 to the minus 14 divided by 3 times 10 to the minus 2. Can I go on?
Yes.
So the next slide discusses the fact that we have to talk about something called pH in a little bit more detail. And as a result of that, pH is a loose translation from some French term that means power of hydrogen. So the pH is a huge indication of how much H3O plus hydronium ion concentration is in solution. And they give us a formula that says pH is equal to the negative log of H3O plus. And so I would love for you to get your calculators out, and I would love for you to go ahead and calculate the pH when you know the H3O plus is 1 times 10 to the minus 7.
I don't even know how to do log and regular math.
So what I'm going to tell you is that if you have your calculator,
With the inverse or negative
just
log?
all I want you to type is the negative button, the log button, which is next to the 7. It'll give you negative log with a parentheses. You will type 1 times 10 to the minus 7, close the parentheses, and you should get 7.
Wait, should we use the EE or the times?
EE,
Yep.
the EE. So when you put this in your calculator, it should look like this. Negative log 1.0 E
We're supposed to get 7.
negative 7, and it should give you a total of 7.
Whoa, it's negative, my brain hurts.
1 times 10, negative log is equal to 1.0 times 10 to the minus 7.
How do you do that without a calculator?
Without what?
Without
You can do that without a calculator?
a, how? Yes, how? Yeah, I don't even know, we haven't even learned this, so.
Well, I'm teaching you how to use your calculator. There is a way to do it without a calculator, but like, you need to understand base 10, and if you haven't learned that yet, then let's not try to teach it in chemistry. So are you able to get negative 7? No, just one. Did you type negative log
You said, yeah, but.
1 times 10 to the negative 7?
Yeah, then you get 7. But if.
Negative log 1.0 times 10 to the negative 7 gives me a positive 7.
Yeah,
That's what I said.
you said negative 7.
No, I said times 10 to the negative 7.
You said, did you guys get it?
No.
Yes, I got it.
So we can use a calculator right now?
Yes.
Okay, moving on. This, ladies and gentlemen, are all the formulas you have to memorize for your test.
It's easy, I know I'm ready.
I doubt it. Now, the very, very first formula is one that you are familiar with. It's the KW is equal to H3O plus times OH minus. I gave that to you already. We talked about it. So if I know the H3O plus, I can calculate the OH minus. If I am in the purple square in the upper right-hand corner, if I know the H3O plus and I follow the green arrow down, I can calculate the pH by taking the negative log of the H3O plus. So far, so good. If I give you the pH and I want to calculate the H3O plus, I can take 10 raised to the negative pH to give me the H3O plus concentration. I can use this square as a way to get through any of the things I'm going to ask you to calculate, at least for this part of the unit. There is always a relationship to 14. So whatever your pH is, it has to be, when you add it with a pOH, it has to equal 14. So there's that formula there. And then you have the OH and the pOH concentrations, and we'll talk about that in a little bit more detail in a second, but you need to know all these formulas. I will not be giving them to you on the test.
Is it possible to have DOH?
Type them all in here.
Yes, you can have a pOH. We're going to talk about that. Now, here, you knew the concentration of H3O plus, right? Hannah?
Oh, 40.
So I then went down and I calculated the pH, and from the pH, I was able to calculate the pOH.
Oh, so you're just looking for what it gives you?
Yep. Again, in this case here, I have a 0.25 molar hydrochloric acid solution. Hydrochloric acid is a strong acid, so it breaks apart to that completely. But we remember that H3O plus and H plus are kind of the same. So in this case, because it completely ionizes, I know that I have H3O plus concentration of 0.25 molar. So if I ask you to calculate the pH of this solution, I get a pH here of 0.60. and pH actually does not have a unit. Now, if I ask you to calculate something called the pOH, (13.4) equals the pOH. And if I know the pOH and I want to calculate the OH minus, I could use this formula.
This is so weird.
I get 4.0 times 10 to the minus 14.
What are all those little right? What's the one above it?
Well, what is,
How do you know what formula to use?
That's a good question. The question is, how do I know what formula to use? And the answer is, it kind of doesn't matter as long as you get to one point or another. So if you're looking, okay, right here. What about it?
what is the pOH?
The pOH is the relationship between hydrogen and hydroxide. If pH is how much is a measure of how much hydronium is in solution, pOH is a measure of how much hydroxide is in solution. Can I go on? Now,
I have to go back to that real quick.
so in this problem here, I'm asked to calculate the pH, the pOH, the H3O plus, and the OH minus. So there's a couple of formulas that I know. KW is always 1.0 times 10 to the minus 14. H3O plus, OH minus, pH, pOH. Now, what do I have here? Do I have an acid or a base? How do I know? Because it has H. So this is nitric acid. So HNO3 dissociates into H plus and NO3 minus. So as a result of that, the H plus and the H3O plus are kind of the same thing. So that means that if I have 0.125 molar HNO3, I also have 0.125 molar H3O plus. So I have 0.125 molar here. So I'm going to go ahead and look at my magic square and say that I'm going to take KW equals H3O plus times OH minus, and 1.0 times 10 to the minus 14 is equal to 0.125 molar times OH minus. So that's going to give me a concentration for my OH minus to be 8.0 times 10 to the minus 14. So from there, I can do one of two things. So I can calculate the pH, which is the negative log of H3O plus. So the pH will be the negative log of 0.125 molar. I can also calculate the pOH, which is equal to the negative log of OH minus. The pOH is equal to the negative log of 8.0 times 10 to the minus 14. So the pH is equal to the negative log of 0.125. So I get a pH equaling 0.903, and the negative log of 8 times 10 to the negative 14 gives me a pOH equal to 13.1. And if I say that I have 0.903 plus 13.1, I get a value of 14-ish. So what I'm saying here is that the pH plus the POH always equals 14. Is there another way to have done this? Absolutely.
You can use any equation,
As long as you show your work, as long as you follow the format, yes. So is this a solution acidic or basic? Based on the pH, it's acidic. pH is less than 7. Yes, so it's pretty acidic. Yes, sir.
So we technically we just need to memorize one equation.
I think you need to memorize more than one.
So maybe like 2.
Probably 3,
How many are there? 4?
like 6. All right, you try this one. Try this one.
Gotta try this one.
Mr. B,
Have you finished this one yet?
what do you think?
So, okay,
Can I ask you a question?
about this,
No.
try again.
Yes?
Why don't you try this?
Okay.
Alright, Mr. B. You know, like your last example, how'd you know H3O plus was 0.125 then?
What type of a solution was it?
Acid. Right?
Hmm?
So all acids have that?
Yeah, all acids are 0.125, all of them.
What about bases?
They're all 0.125.
Oh, really?
Just memorize that. I hope you understand that was complete and total sarcasm.
Wait, oh, dude, I actually believe.
I did, I believe them too. You can't, I
Mr. B.
was legitimately
Yeah.
asking a question.
Right, and I've legitimately covered that like 4 times today. Somebody want to tag in?
Alright, please.
Yeah, I don't know what he is.
So how did he know H3O plus was 0.125?
Wait, yeah, how?
I don't think.
Stated it in the,
Oh, it did.
yeah.
It did.
Oh, boy. Mr. B, can I take honors chem again next year?
Yeah, if you fail this semester.
Oh, we're good, dude. Gotta be plus.
So then no.
Darn it.
Have Sabine class again?
66.
As mentioned before, there's more than one way to do this problem, but this is how I chose to do this problem. Again, you have that magic square, for lack of a better term, to help you figure out what formula to use when. What I'm telling you is that at this particular point in time, this was the easiest way I thought to do this problem. But like I said, there are other ways to do this problem, but this is the one that worked for me. Questions about this problem? There is homework.